Bismillahirrahmanirrahim. Welcome to Dr. K's Academy. My name is Engineer Rahman Ali Khan. Let's start the lecture number 14 of Building Construction Engineering. So the outlines of this lecture are joints in building. So we will discuss this in detail in this lecture. We will discuss its types, its general configuration, and installation. So we will discuss each type of joints in details, its configuration, installation, in separate parts of this lecture. We will discuss the jointing material, and at the last we will discuss plane protection. Joints in building. So the separation or planes of weakness introduced at different locations in a building are known as joints in building. So it's referred to intentional separation or planes of weakness that are introduced in various parts of structure. These joints are crucial for maintaining the integrity of a building because they help to absorb accommodate dimensional changes that occur due to environmental or material related factory. So why joints is necessary in a building? So buildings, especially large ones, are subjected to expansion and contraction due to temperature changes. As temperature rises, buildings material expands, and as it falls, they contract. So this can cause stress in structure and the variation in moisture content. So material like concrete, bricks, and wood can absorb or release moisture, causing them to swell or shrink. So without joints, these dimensional changes would lead to structure failure like cracking or even partial collapse in severe cases, and disfiguring cracks, which may not be dangerous but can be unsightly and allow water ingress. Joints are usually provided in large and multi-story buildings. So in large or tall buildings, temperature and moisture changes can cause significant expansion or contraction of a building material. So if joints are not provided, these movements cause uh, stresses with the structures, which can result in cracking, distortion, and structural damage. So we use for the magnitude a thermal expansion or contraction formula, which depend upon uh, change in length of thermal expansion, original length, coefficient of thermal expansion, and change in temperature. So let's discuss this, what it's mean in building. So longer buildings mean a larger L, and greater temperature variation cause more expansion or contraction, and different material expands differently due to varying of thermal coefficient. For example, steels expand more than concrete. Therefore, in a design of large or multi-story buildings, these movements must be considered to avoid uh, damage. So joints allow movements to occur safely without cracking or stressing the structure. So providing joints in large building helps manage movement due to thermal and moisture changes. Using thermal expansion formula, engineer can calculate expected movements and designs appropriate joints to protect the building from stress and failure. Types of joints. So there are different types such as expansion joints, contraction joints, sliding joint, and construction joints. We will discuss each its configuration and installation in details in the coming slides. Expansion joints. So the joints are provided to accommodate the expansion of adjacent parts in a building are known as expansion joint. So expansion joint are a special type of joints introduced in building to allow moments due to thermal expansion. So when different parts of a building expands because of rising temperature, they push against each other if no space is left to accommodate this moment. Compressive stresses develop, which can lead to cracking or structural damage. So the purpose of providing expansion joints are to absorb or accommodate expansion of adjacent section of a building caused by temperature increases. So expansion joint essentially consists of space between two parts. You can see here in the figure. So in structure, it's typically consists of gap or space between two parts of a building. These gaps allow each part to expand freely without pushing against the other. And sometimes loading transmitting device such as metal plates, dowels, or flexible material that helps transfer load across the joints and while still allowing movement between the section. So now let's discuss in which buildings especially we have to use expansion joint. So expansion joint commonly used in long masonry walls, reinforced concrete buildings, and bridges. So it's especially important for buildings which have larger length and located in area with high temperature variation. So without expansion joints, the structure cannot expand freely, and compressive stresses builds up at certain points. So these stresses can lead to cracks in wall or slabs, buckling of structure members, and long-term damage to the building. So location separation and a number of joints shall be properly designed and detailed depending upon the types of material used in buildings. So different material expands and contract at different rates. Steel has higher coefficient of thermal expansion than concrete. Masonry expands less but may still crack if restrained. So the material type directly affects how much movement is expected, which is turn affect how often joints are needed. Length of the building. So longer building experience more thermal moments. As the length increases, the need for more frequent expansion joint increases. You can see it's a direct relation in thermal expansion formula. So example of this is in concrete structure, joints are often placed every 30 to 45 meters depending on local condition. So we discussed that as length increases, the need for a frequent expansion joint increases. Temperature changes. So the greater the temperature variation in summer and winter, so the more the building's material will expand and contract. In hot or cool climate, more joints are needed to accommodate the wider range of movement. Exposure to weather. So building exposed to direct sunlight, wind or rain will face more environmental stresses. Exterior wall and roofs especially need properly designed joints because they are more affected by weather than interior elements. Time of construction. So if different parts of buildings are constructed at different times, their shrinkage, covering, and setting may vary. So providing joints between such sections helps avoid cracks due to differential moment or settlement. So after placing joints, the gap is often filled with flexible material like rubber, silicone, bitumen-based compounds or foam. So these flexible sealants keeps out water, dust, and debris, allow free expansion and contraction, provide durability and waterproofing without restricting movement. So expansion joint must be carefully located and detailed by engineer based on the structure size, material, climate, and construction timing. Properly designed filled with flexible material protect the buildings from stresses, cracking, and long-term damage. ensuring performance and safety. So now let's discuss installation of expansion joints. So the art of providing expansion joints to accommodate expansion of adjacent parts at different location in a building is known as installation of expansion joints in the building. Masonry wall. So in first in load bearing wall. So the function of load bearing wall is these walls carry the load of the building, uh, e.g. from floors, roofs, etc. So in this expansion joints are typically from 1 to 2 inches wide, and the spacing between the joint is 100 feet. So since these walls are structured larger, joints width and spacing helps absorb greater movement due to loads and expansion. And large and non-load bearing wall, so these are not taking the loads of floors and roof, etc. So in this the expansion joint's width is from 0.5 to 0.75 inch, and the spacings between the joints are 20 to 40 feet. So these thinner walls are more vulnerable to cracking, so joints must be provided more frequently to relieve stresses. So after an expansion joint is created in a masonry wall, it must be properly sealed and finished to maintain its functionality and protect the structure from water, dust, debris, and insect entry. So the methods of sealings depend on the width and location of joints. So in case of small joints, only a sealing compound like silicone, polyurethane, or bitumen-based sealants is used. These compounds are flexible and can stretch or compress as the joints move, and it is ideal for non-structured smaller joints where minimal movement is expected. So small joints are less than 0.75 inch. In case of wider joints which have thickness more than 0.75 inch, so a joint filler like usually a compressible material like foam, rubber, cork, or bitumen board is placed inside the joint gap, and a sealing compound is then supplied on top of the filler. So this two-part system fills the joint's depth efficiently, allow for movements while sealing the top surface against water and dirt. And it is used in larger structure joints where a significant expansion or contractions occur. In case of boundary wall joints, during construction, thermopore sheets, lightweight compressible insulation boards, may be placed in the joints gaps. So thermopore acts as a temporary pillar, allow for expansion, and it can be later sealed with a sealant or cover for weather protection. For seepage control, we use a water stopper or water bar. So in water retaining structure like tanks, basements, retaining walls, water can seep through joints. So to prevent this, a water bar uh, is embedded within the joints during construction. So it acts as a barrier to stop water from penetrating through the joints. Very important in area exposed to water pressure. Here you can see we have installed the water bar in the joints. Installation of roof expansion joints. So expansion joints are not only used in walls and floors but are equally important on roofs, especially in larger or long span buildings. So the roof is directly exposed to sunlight, rain, and temperature variation, making it highly prone to thermal expansion and contraction. So now let's discuss why we provide expansion joints in roof. So roof expands during the day and contract at night. So without expansion joint, these movement can cause cracks, leaks, and water seepage, damage to waterproofing membrane. So now let's discuss installation. So an effective water seals roof expansion. Joints must be sealed carefully to prevent water penetration. The sealing system must be flexible and waterproof, allowing movements while stopping water. Sealants, metals covers, waterproof membrane, and protective flashings are often used together. Use of water bar. So water bar are installed within the joints to create an internal waterproof barrier. These are often made of PVC, rubber, or metal and embedded at the time of concrete pouring. So this stops water from seeping through the joints into the building. Construction consideration. So in construction consideration, the joint is usually covered with a metal cap. Here you can see it's a metal cap with a or flashing to protect it from UV rays and mechanical damage. So waterproofing membrane are left over the joints area and sealed tightly. In case of a large roof area, joints are spaced properly according to design and climate condition. Installation of expansion joints and floor. So in case of floor, water bar may not be necessary. If an open joint is not acceptable, a cover plate you can see in the figure fixed to one side and free to slides over the concrete on the other sides may be provided.